Today we're working on section 11.3, which is to solve radical equations. The steps to solve radical equations: the first is to isolate your radical on one side of the equal sign. Then we are going to square each side of the equation. And finally, we are going to check our answer. You need to do this on each and every problem. Our first problem is 3 square root of x minus 6 equals 0. We want to get the square root of x all by itself. We want to isolate that radical. So 3 square root of x, we move the negative 6 to the other side, so it becomes positive. Then we can divide by 3 on both sides, which gives us the square root of x is 2. Now that we have that isolated, we can square both sides of our equation so that we get rid of the square root sign. The left-hand side will just give us plain old x, and the right-hand side will give us 4. Substitute that answer back into the original equation and make sure that that works for our equation. We have 3 square root of 4. We know the square root of 4 is 2. And that will give us 6 minus 6, which is supposed to be equal to 0. And yes, that does give us a true statement. 0 equals 0 in the end. So we know that this is the only answer that we have, and it works. So therefore, we have an answer on this one. There are a few more things to do on this problem. We need to move that 9 over to the other side first. So we have 2 times the square root of x plus 6 equals 12. Then we can divide both sides by 2. We have the square root of x equals 6. Square root of x plus 6 equals 6. Then we can square both sides because we've isolated the radical. That will give us x plus 6 equal to 36. And when we subtract 6 on both sides, we find out that x is equal to 30. In substituting this back into the original equation, we'll have 2 times the square root of 30 plus 6 plus 9 equals 21. And we know 30 plus 6 is 36, so we have the radical 36 written in our expression. And the square root of 36 is 2, so 2 times 6 plus 9 equals 21. And that gives us 12 plus 9 equal to 21. And we can see that, yes, 21 equals 21. So we know that this is our correct answer. X will equal 30. When we have radicals on both sides, you've gotten them isolated, one on each side. Then go ahead and square both sides so that you can get rid of the square root signs. That gives us 4x minus 12 equal to x plus 3. We want to move our like terms together, so let's move the x over with the 4x. That gives us 3x minus 12 equals 3. And then let's move the negative 12 over to the other side so that we get our constants together, and that'll be 3x equal to 15. Finally, when we divide by 3, we find out x is equal to 5. When we substitute this back into our equation, we are looking for the answers to be exactly the same on both sides. So underneath the radical, we have 20 minus 12 under our radical. On the right-hand side, we've got the square root of 8. And we know 20 minus 12 is 8. So we have the square root of 8 equals the square root of 8. True statement. Therefore, this is our answer, x equal to 5. If both of your radicals are on one side, you cannot start squaring here. These two radicals must be on opposite sides of the equal sign for you to start working on this. So please move this minus the square root of x over to the other side so that we have the square root of 4x minus 3 equals the square root of x. And now that your radicals are on opposite sides of the equal sign, they're isolated on their own side, then you can square both of the radicals. That gives us 4x minus 3 equals x. And let's go ahead and move the 4x over, so we have negative 3 equals a negative 3x. And when we divide by negative 3, we find out that x is equal to 1. Substituting back into the original equation, we have the square root of 4 times 1 minus 3 minus the square root of 1 equals 0. 4 times 1 is 4 minus 3 gives us that square root of 1. And we know a number minus itself is 0. This is really 1 minus 1 equals 0. And we get a true statement. So we know that x is equal to 1. When we solve equations that have extraneous solutions means that there is an extra solution that will not work in the original equation. It'll work in an equation that we had to change it into, but it won't work in the original. So that's why I do ask you to check your answers. Up here we have the square root of 20 minus x all by itself already on one side, so we can square both sides of our equation. When we do so, that gives us 20 minus x equals x squared, and now we are working with a quadratic equation. Let's move both of the left terms over to the right-hand side so that we end up with x squared plus x minus 20. We can complete the square to solve this. We could use the quadratic formula to solve this, or we could use factoring. I'm going to factor this one. It's a very easy one to factor. X plus 5 and x minus 4 equal to 0. We set each of our factors equal to 0, and we're going to find out that our two solutions for this quadratic equation are x equal a negative 5 and x equal a positive 4. The deal is we need to check both of these solutions, though, in our original equation up here. And when we put those numbers back in, let's put the positive 4 in first. We got the square root of 20 minus 4 is equal to 4. Well, 20 minus 4 is 16, so we have the square root of 16 equals 4, and we know the square root of 16 is 4. This is a true statement. We know x equals 4. That's one answer that will work. Let's put the other answer in, the negative 5, and that gives us a square root of 20 minus a negative 5 equal to a negative 5. 20 minus negative 5 is the square root of 25 equals a negative 5. We cannot take the square root of a number and get just a negative. We're not solving for an x in this equation. We are just simplifying. And so we cannot come up with the square root of 25, which is 5, equal to a negative number. This is a false statement. Therefore, we throw x equal a negative 5 out as one of our answers. We can only use x equal 4 in our original problem. Yes, I know, negative 5 and positive 4, they both work for this quadratic equation, but they do not work when we have the square root in that original equation. So please be very careful to check each and every one of your solutions. Thank you and good luck.